Hello and welcome to today's session. So today's session is part of data warehousing and data mining course, and the course code is MCS 221, and today's portion has been taken from block 4 unit 10. So if you remember, in the last class we talked about classification techniques and where we saw how the decision trees are going to be useful for various purposes. We talked about what are the importance of classification techniques in data analysis, why particularly we should use the decision trees, and decision tree pruning, where we saw that this is one of the methods which is actually helping us to remove the attribute which are not necessary. Then we also talked briefly about algorithms for the decision tree induction, and finally we talked about how to extract the classification rules from these trees. So today's session I'm going to talk about one of the important topic which is also related to the decision tree, because when the machine has to build the decision tree, it uses the various measures. So we will talk in detail about attribute selection measures. There are various methods available like information gain, Gini index, gain ratio, but today's session I am going to talk about information gain, and then we will take one example and we will try to understand how this information gain can be used to build the decision tree. So if you remember, in the this is what I am going to show you today. So this is a one thing. At the end of the session we will see how this particular diagram or this particular decision tree is going to be useful. So there are various attributes in a given data, and we will see that why age is taken as a root node, right? So this is what exactly we are going to talk. So if you remember, we talked about classification, which is a very important concept in data analysis, particularly when we talk about machine learning, data science, and basically it refers to the process of categorizing or some kind of labeling data into the predefined classes. So all these predefined classes are already available in the data sets, and our primary objective of classification is to assign an unseen data point and to see how this can be used for predicting the new data. Though there are many classification methods available for data analyst and machine learning practitioner, but one can choose depending upon the nature of data, the problem requirement, and the desired outcomes. So in particularly, this is what exactly we talked in the last class. So briefly, once again, I'm going to talk how the decision tree works. So basic algorithms. So tree is constructed in a top-down recursive divide and conquer manner. So in the beginning, what happens? All the training examples are at the root labels, and all the attributes which are categorical, and if they are continuous values, they are going to be discretized in advance. And then recursively we are going to follow this, and then we will use one of the attribute selection measures to select which of the attribute is going to act as a root node, then followed by a sub node, and then at the end we will have a leaf node. And leaf node is basically representing your classes. And then there are multiple conditions for stopping the partitioning here. So all the samples for a given nodes belong to the same classes. So we will continue this recursive process till we see that there is no sample left. So let's start what exactly the attribute selection measure does. So basically it's one of the factors, one of the measures, which is a heuristic techniques for selecting the splitting criterias. So when I say splitting criterias, we have a decision tree where we are going to have a more number of attributes, and from a given attribute, which of the attribute is going to be act as a root node, and followed by subnode, and finally the leaf node and all. And these splitting rules, this is also known as a splitting rules, because they determine how the tuples at a given nodes are going to be split. So basically what it does, it provides some kind of ranking based on some attribute describing for a given training attributes, and then based on the one which has the best score for a given attributes, that will be taken as a root node here. So basically there are multiple techniques available, and we will be talking about the information gain today. So what happens when we talk about attribute value selections? We are actually going to calculate the expected information required. We are going to talk about various other measures which we need to calculate for calculating this information gain. As I mentioned, we have a various selection criteria like information gain, gain ratio, Gini index. And today's session we will be talking about the information gain, which is very, very important for the algorithm ID3. ID3 is one of the decision tree algorithm where we actually use the information gain splitting criteria techniques. So what we will have? So we will have a data partition, and we know that whenever we talk about machine learning techniques, because this classification techniques belongs to the supervised learning, right? And where we have a training data sets, part of training data sets, and then we'll also have a testing data set. And based on these training data sets, what we are going to do is we are going to train the system. And when we are going to train the system, finally when the unseen data is given to the system, it is going to tell us like this particular data belongs to which class or not, right? So we will have a data partition, and we'll have a training set of class labeled tuples here basically, because we are talking about the supervised learning. And node AND is going to represent or hold the number of tuples of data partition D. And then we are going to calculate class label attribute which has a M distinct values, where M define the number of distinct classes. For example, if you have a rainy, sunny and cloudy region, that means the M is going to be 3. And then what we are going to do is we are going to calculate the C of ID, base ID, which is going to be the set of tuples of a class CI in D. And then we are going to determine the mode of D and mode of CID, which denotes the number of tuples in the CID and D respectively, right? Then based on that, what we are going to do is we are actually going to calculate the information gain techniques, and based on the information gain we are going to finally calculate the value for each attributes. So in the beginning we are going to start with the expected information. This is for the complete data set. So when I say info of D is equal to minus summation of I to M and pi log base 2 and pi, and where pi is the probability where an arbitrarily tuples in D belongs to the some class CI, which is estimated by mode of CID by mode of D. So what exactly we are going to do here is we are going to calculate first the expected information tuples for the complete data sets, and followed by what we'll do is we'll calculate the information gain for the every single attribute we have. And we are going to look into the one example where we'll see that how exactly that information gain is going to be calculated. And based on that, the one which has the highest information gain values or score, that is going to be selected as a root node. And similarly, that is going to be repeated every time. And then we'll have a sub node, and finally we'll have a leaf node and all. Right. So let's look into the, after calculating these expected information, what we are going to do is we are going to calculate the what we call information required to classify a tuple, which from the partitioning by A. A is an attribute basically here. So info of A of D is equal to summation of J is equal to 1 to V, and dj, mode of dj divided by mode of d, basically it acts as a weight of jth partition. So what basically what we are doing is we are actually calculating the information, expected information for each and every attributes here. And finally, once we have a information gain for that particular attributes, then finally we are going to calculate by gain is a is equal to info of D, which we have already calculated earlier for the complete data set, minus info of A of D here. This we have to calculate for each and every attributes. So let's look into the example here. And finally, as I said, the attribute A with the highest information gain A is going to be chosen as a splitting value at a node N here. So what we have done here is we have taken one example where we have two distinct classes, whether the person is going to buy a computer, yes or no. So one can see that two distinct values, yes or no, and therefore we have two classes, and let's assume that class C1 belongs to yes and class C2 belongs to no, and we have a total 9 tuples which belongs to yes and 5 tuples of class no. It means we have a totally 14 tuples are there, and which we are going to be used to calculate the first expected information for complete data sets, data partition. Then we are going to start calculating the information, expected information for each and every attribute. And finally we will see the difference, and the one which has the highest information gain value is going to be act as a root node and all. Okay, so now let's look at this particular table where you can see that we have a 14 tuples here, and starting with the RID, that is row ID, we have a age as one attribute, we have a income, we have a students, whether we have a credit rating, and finally we have a class labels, that is whether the particular student is going to buy a computer, yes or no. So one can see that these are the predefined classes, and that is what the main reason we are using for the supervised learning. So in supervised learning, what happens, all these labels are predefined, so these are known, right? And based on these known values, what exactly we are doing is we are actually calculating the and defining the various parameters, and based on that you train the system and finally predict the values. As you can see that we have a 9 yes and 5 no's, and we will see that age has a 3 different categories: youth, middle age and senior. Income also we have a high income, and the medium we have a low. Again we have a 3 different values. Student, whether they are student yes or no, you can see that there are different things. And credit rating is also we have a fair, excellence, that is what exactly we have a 2 different values. And finally we have a whether they are going to buy a computer, yes or no. Now what we have to do, so to find the splitting criteria, as we mentioned in the very beginning of the session, that splitting criteria or attribute value selection for all these tuple, we first have to compute the information gain for the every attributes we have. So we will start with the information, expected information to classify a tuple in D by the formula what we have seen earlier. And if you put on that value, we have an info of D is equal to minus 9 by 14. That is what we have, because 9 is yes and 14 is the total number of values we have, right? And then we have a log base 2 of PI, and you can see that PI is basically we have a 9 by 14, so that we are calculating for the yes, and then minus what we are doing is 5 by 14 here. So 5 is basically the all the tuple which belongs to no classes, right? So 5 and total number of attributes are 14 here, and again we'll use the formula log base 2 5 by 14, and we if you compute the complete these data, we get the value of 0.94 bits here. And once we have a information gained, expected information for your data partition, what we have to do is we have to compute the expected information for each and every attributes. So how exactly we are going to do? We will be using those formula once again, and we will calculate the information gain for each and every attributes. And once we get the information gain for that particular attributes, and the gain is basically a difference between the expected information of complete partition D minus information gained what we are going to receive from the each attribute, and we will finally going to calculate the one which has the highest score, and then that is going to be useful for the splitting criteria or root node here. So we can start with any attributes. So let's take the attribute age. For example, one can start the same thing with the other attribute as a student or credit rating or any other attributes we have. So we have started with the attribute age, and if we need to look at the distribution of yes and no tuples for each category of age, so if you further categorize the age, so we mentioned that we have a youth and we have a middle age and we have a seniors. So one can see that we have a 2 tuples which belongs to yes and 3 tuples which belongs to no for the youth category, and for the middle age we have a 4 yes and 0 tuples for the what you call middle age here. And for category seniors there are 3 yes and 2 no tuples here. So this is what one can see here. If you look at this data, you can actually see that for the age attributes youth, middle age and seniors, this is what exactly the values we are going to get it further. And now what we have to do? So once we know that there are further category in the age attributes, so we have to calculate the expected information for that particular attribute, and right now we are calculating for the age attribute here. So to classify a tuple in partition D, if the tuple are partitioned according to the age, in that case what we are going to have is we are going to have first we are going to have a 5 by 14. 5 by 14 is for the youth category, right? 4 by 14 is for the middle age, and the 5 by 14 again, if you look at the third line, that is for the senior category here. So 5 by 14, and in 5 by 14 further it is categorized like we have a 2 yes and 3 no, right? So you can see that 2 by 5 is basically 2 tuples which belongs to the youth of out of 5, right? And log of base 2 of 2 by 5 minus 3 tuples which belongs to the category no out of these 5 tuples. And similarly we have to calculate for the middle age. So we saw that there are 4 yes in the middle age and 0 tuples for the no category here, right? So similarly we calculated for 5 by 14, and out of 5 we have a 3 tuples which belongs to yes category and 2 tuples which belongs to the no category for the senior one. And once you calculate the information gain values, so what exactly we get is 0.694 bits here. So this is what exactly we get it finally here. Now, once we get this information, expected information for the complete data partition and information gain for the age attribute, so what we have to do is we have to calculate the gain. So we have to calculate the gain values for age attributes. So in this this particular category, we have a 0.940 minus 0.6940, which is coming somewhere around 0.246 bits here. Now, as I mentioned in the beginning, because this is a recursive process, the whole algorithms works in a recursive manner, so we have to calculate the information gain for the remaining attribute as well. So what we have to do, we have to calculate the gain for the income, we have to calculate the gain for the students attributes, and we have to calculate the gain for the credit rating. So if you remember, there are 4 different attributes which has been shown in the, if you look at this particular data set here, trading tuples. So you have a 4 different attribute: age, income, student, and credit rating. And the class is basically your final attribute, right? Final class. So based on the values what we have for a particular tuples, we either get yes or we either get no. So once we have a gain for age attributes, similarly we have to calculate the gain for income and remaining attribute as well. So in this case, once you put the values according to the formula which I have mentioned here, so gain of income is coming somewhere around 0.029 bits, and gain of student is coming around 0.151, and gain of credit rating is coming somewhere around 0.048. And if you compare all these gain values, you will find that the gain value of age is the highest, right? And that's the reason gain of information age is going to be categorized as a root node here. And further, what we'll do is we will be able to finally compute all the values, and this process is going to be repeated again and again until we compute the values for all the remaining attributes. And this is what we have. So because age has the highest information gain among all the attribute, it is selected as a splitting criteria, or it is selected as a splitting attribute, right? And node n is labeled with the age, and branches are grown for each of the attributes values. So we know that there are 3 categories, right? So we have a youth, we have a middle age, and we have a senior. So these are the 3 things. So we know that age is the one. If it is age youth, that we know that there are how many tuples? If you remember, there were 5 tuples. Out of 5 tuples, there were 3 no and 2 yes. For yes, we have you can see that there are 4 yes but no or 0 tuples with a no class. And then we have a senior attributes where you can see that we have a 3 yes and 2 no. And what we have to do is recursively we have to calculate the values for the remaining attributes. Now what we'll do is we will start with the youth one. So you will further calculate the value for income, students, credit rating, and class. Now earlier in the beginning you have 14 attributes. Now you have to start calculating the information gain value for the youth first, then middle age, then for the senior. So similarly what you are going to do is you will first calculate the expected information for the training data set. In this case your training data info of D will become the youth. So you will have only 5 tuples. And out of those 5 tuples, and again what you have to do is further you have to calculate and compute the information gain values, right? and that is going to be repeatedly for the remaining attribute as well. So you will have to compute for middle age, you have to do it for what you call senior category as well. And this is how you are going to get the final decision tree. And just imagine that this is what the machine does. This is what the your machine, the moment you give the training data sets to the machine, and it uses the classification technique, one of the classification technique as decision tree, which uses the information gains attribute selection criteria. So what it does is it actually calculates the information gain, and finally you have a complete tables or complete tree, decision tree, right? Starting from root node to the leaf node. And from the each node or each path from the root node to the leaf node is your last node basically, right? So root node to the leaf node basically one rule. So we know that one can say that if age is youth, you come to the left side, right? If age is middle, you come to the middle one. If age is senior, you go to the right one, right? So further, what you will have based on the further processing of your data, you are going to calculate and you are going to have a sub node here. So you have a root node, then you have a sub node, and further you will reach to the different values until you will compute till you get the final leaf node and all. And this is how the decision trees are going to be formed. So I hope you understand how the attribute selections measures are used for building the decision trees, right? And we know that decision trees are one of the major techniques for the classification, where we have seen that attribute selection measure which has a different techniques, but today's session we talked about information gain, where we have calculated the information gain for the complete dataset partition. Then we started calculating the information gain for each and every attribute, and then we see the difference, and the one which has the highest information gain values, and that is going to be selected as a final node, right? And this is what we have discussed today. And in the next sessions, I'm going to talk about the remaining classification techniques, as there are many techniques available for the classification, and classification which is basically based on the supervised based learning, where all your data set has a predefined data, right? Predefined labels are available. So some of the application we mentioned earlier, it can be used for the weather forecasting, it can be used for predicting the stock market values, it can be used for various other things where you want to know that if you have unknown data, what is going to happen in the future. All that is possible once you have a classification techniques with us. So for further things, we will meet in the next class. Thank you.
We welcome you to join the bouquet of programs offered by the School of Humanities, the Indira Gandhi National Open University, New Delhi. The Indira Gandhi National Open University, New Delhi is a mega university today. It was created